It's your favorite earth science teacher back to go over seafloor spreading and hotspots. So, excuse me for a sec. Okay, so currently you see this model. It's the ocean floor. You notice you have the asthenosphere right here. So the asthenosphere works by convection currents that are being driven by heat from the mantle or interior or inner core, creating all that heat, which is heating up the magma in the asthenosphere. And when things heat, remember, they are less dense, so they're going to rise. So what happens is as this magma is rising, it finds this rip in the ocean floor, this cut. Just like I said before, when you cut yourself, blood comes up. Well, with the ocean floor has this huge cut, and you can actually see it in Google Earth. And when the magma comes up, it solidifies and pushes out the old ocean floor symmetrical from the ridge right here. And you get new ocean floor that forms right next to the ridge. So two vocabulary words you're going to hear me a lot say: rift and ridge and rift valley. So a rift is the process of the ocean floor ripping open. A rift valley is a noun. A valley is a low area of elevation. The valley is actually where the ripping is occurring, and the ridge is an area of higher elevation right next to the valley where the magma is solidifying on top and on top and on top, and then eventually flowing over and pushing the ocean floor out. Okay, so again, same type of questions being asked over and over again. What motion of the seafloor is causing this? Divergent and seafloor spreading. What you're going to notice again, and when you watch that video, does a better job explaining it than me. It's one of the scientific mysteries of life. So currently, the rocks that are forming right now are igneous, and there's iron in them, and they take the magnetic polarity right now of the Earth's North Pole, and we call that normal polarity, so there's a plus sign. But a couple of thousand years ago, before, we had what was known as reversal, and the magnetic poles actually reversed, and there was a reversal charge, negative, which was over the ocean crust. But you're noticing that it's symmetrical. What's on the right side is on the left side, like a mirrored image, a reflection, and it's symmetrical. You can think of this maybe as like your y-axis, and what you see here is a reflection on the other side. Very important. Scientists believe that a reversal might be occurring sometime in the near future. They can detect it at airports. It throws off air traffic control symbols, or signals. So if you're really interested in that, I would suggest to Google. It's very interesting. And again, they're not really sure what causes it. Okay, so I did all the math down here. I left my stylus upstairs. I was lazy to go get it, so sorry if you can't read this. Let's just go over this. The rock that is forming at the mid-ocean ridge would be igneous, and it would be fine-grained because it's extrusive. This is where magma is coming up and from the asthenosphere and solidifying. And 7, the oldest rocks would be found furthest from the ridge. So let's say like ocean floor by the continents, by the east coast of the United States, or the west coast of Europe, something like that. So if I did my math correctly, if the ocean floor is moving 3 centimeters per year, how long would it take to widen a kilometer? So in 1 kilometer, there's 100 centimeters. So I did the work, and it would be 0.3 kilometers per year. And to figure out how much of a year, that would be 300 years. Correct me if I'm wrong. Encore, you're on that. Or Serena, you guys get on my technical errors there. All right, so currently at the ridge right now, the polarity is called normal polarity. Again, that might be changing. We're not sure when, but scientists believe it's soon, possibly in our lifespan. All right, the youngest rock would be right next to the ridge, so zones B and C, and the oldest rocks would be found further away, A and D. And then I was a little off because, again, I left my stylus upstairs. The mid-Atlantic ridge would have your youngest rocks, and it would be symmetrical, so it makes like this V shape here, where your oldest rocks are further away. So I said right here, sorry, this is really hard to do on a computer. So your answer should be symmetrical to the right side. So I tried to say, oh, normal polarity was red, so this should be red, and then blue, and then red, and then blue, and then a big section of blue, and then red. So sorry, it did not come out nice. Oops. All right. Hotspots. Again, one of those mysteries, why we have these hotspots all over the Earth, but it's an area where magma is continuously rising up from the asthenosphere, and the spot does not move when the plates move. And evidence of this are your Hawaiian Islands. So the current island of Hawaii is over the current hotspot. So volcanoes on the Hawaiian island, not like the state of Hawaii, but the actual island that's called Hawaii, I know that's a little confusing, has active volcanoes because it is over a hotspot. So magma is continuously rising up. Which Hawaiian island from here is the oldest? So if you look on the diagram, Kauai is the one furthest away from the hotspot, so that would be the oldest. But at one time, Kauai was on the hotspot, and these other islands did not exist. And there's a really nice simulation on the HyperDoc, so I hope you watch that simulation because it's a really, 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 really much better job than what I'm about to show you. So you have this area, I'll use red for hotspot, and the magma is coming up, but the plate continues to move, so it drags along with it its islands, and then you've got an island here, and a new island will form. Okay, so why are these islands smaller as you get away from the hotspot? Well, anytime anything gets smaller is due to erosion. Over time, waves and wind will cause erosion to make the island smaller. And if you were to go, exploring volcanoes on Oahu or Maui, you would not be in any danger of any volcanoes erupting because you're not over a hotspot, so there's no magma. So if you ever get a chance to leave your house again and make it to Hawaii, those would be the islands that you could go into the volcano and take an expedition there. Predict where the next island would form. Be specific. So these islands are moving, or the plates are moving northeast, so the next island would form correction. The plate is moving northwest, so the new island would form southeast of Hawaii. Okay, so which direction is the Pacific plate moving? Northwest. Follow the chain of the islands. And again, same answer. I forgot I asked the question like 3 questions before, so sorry about that. And defend, locate Midway Island. If you look at Midway Island, you can kind of trace the islands back to Hawaii, where Midway was once over this hotspot. So I would say defend. The islands move northwest from the Hawaiian Islands, and they follow that pattern and that chain of islands. All right, so please, on the HyperDoc, there's a couple of good videos to watch. They're not that long. There's a couple of good simulations. They're also not that long. Do the work. It's pretty interesting stuff. And I will either have seen you at the meets or I will see you at the meet. And on Thursday, you will have a hotspot lab that will be due on Monday night. So either do that on Kami or do that on Google or take a picture of it and send it to me. But the labs I will need to see because I will be grading it for a grade in the gradebook. All right. It is now time for Mrs. Perno to go to bed. I will see you soon.